So guys, we are here with the third question of friction. So you can read the question now. There, it's also an inclined problem where the object is placed on an inclined plane, which is having some theta. Okay, let us read the question now. What should be the value of angle theta so that motion of the block 200 newtons impends down the plane? Okay, so they're asking you to calculate the angle of theta. Okay, so that the motion of the block 200 newtons impends down the plane. It has to move down the plane, and they're asking you to take the coefficient of friction, that is mu is equals to 0.3. Okay, for all the contact surfaces, and figure is as shown here. Okay, so a clear picture of the figure you can see here. So this is the string to which it is connected. Okay, so once you have drawn this figure, this is a sketch. Now let us write this mu is equals to 0.3, what they have given. So this is coefficient of friction. Your coefficient of friction is given by mu is equals to F by R, and you can write F is equals to 0.3 R. So now let us start solving with the block 100 newtons. Okay, so the 100 newtons, the this is the free body diagram of the block 100 newtons. So what you have drawn here, see, this is 100 newton block. So the load is applied in this direction, the plane lies in this direction. Okay, this is the axis, and now this theta is made with the vertical axis. The 100 newtons is making an angle theta with the vertical axis, and this is T. Okay, the string tries to generate tension forces and it tries to move body up the plane. What this string is doing to the body, this string is trying to move 100 newtons up the body in this direction. Okay, so if it is trying to move this up the direction, what does it mean? It means the motion trend is towards upwards. So if the motion trend is upwards, then the friction will be in the opposite direction. That's what I have written, 0.3 R1. Okay, here F is equals to 0.3 R1, that is mu is equals to F by R1. That is what I have converted here. Okay, it is F is equals to 0.3 R1. I have written directly. So now this is the reaction developed because of the load 100 newtons. So now let us try to solve the problem. Now to start with, the resolving forces vertically, that is summation of the vertical forces equals to 0 when you write this. Now next, what are all the vertical forces you can see here? The vertical forces are R1. Okay, R1, and here this 100 newtons is making an angle with the vertical axis. So the horizontal component will be 100 sine theta, and vertical component will be 100 cos theta, because the angle is made with the vertical axis. So R1 minus 100 cos theta is equals to 0. So your R1 happens to be 100 cos theta. Okay, now put this as equation 1. Now sigma h is equals to 0. Summation of horizontal forces equals to 0. Okay, now next, what all horizontal forces we have? T, that is directed towards right side, hence it is positive, and the horizontal component of 100 newtons is, if the horizontal will be directed towards left, hence it is minus 100 sine theta. You have anything else? Yes, you have the friction forces, so it is directed towards left, hence it is also 0.3 R1 is equals to 0. So now substitute the value of R1 in place. Okay, in place of R1, so it is plus 100 sine theta and plus 0.3 R1. What is R1? It is 100 cos theta. So your T is equals to 100 sine theta plus 30 cos theta. When you multiply this 0.3 to 100, you will get 30 cos theta. So this will be your equation 2. Now this was block 100 newtons. Now let us solve the block 200 newtons. Okay, so this is angle made. So this is 200th block. So this is the axis. Just draw the axis like this, and the load is acting in this way, that is 200 newtons. So now whatever reaction was there at block A, that is 100 newtons, okay, 100 newtons, so that will act here also in this way, okay. This reaction I'm talking about, whatever reaction has developed under block 100 newtons, so it will be acting as a load to this 200 newtons. So this is R1 acting downwards, okay, R1. Now how was the motion trend? Now what is happening to 200 newtons? The 200 newtons is moving downwards, okay. The motion trend is towards downwards, both up and down. This is motion trend, okay. This is motion trend. So what is motion trend? Motion trend is along which your body is intended to move. So when the motion trend is towards left, definitely the reaction, that is the coefficient of friction, will be towards right side. So this is coefficient of friction. So this is the reaction developed, that is R2, okay. Now we are solving the block 200 newtons, hence this is the friction between 100 newtons and 200 newtons, that is 0.3 R1, that is okay, friction F1. Now here it is friction F2, so F2 is equals to 0.3 R2, fine. So now solving vertical forces. So in vertical forces, what all we have, this is R2, that is towards upside, R1 is down, okay. Let us write this properly. And next, this 200 is making an angle theta with the vertical, hence the vertical component of that will be minus 200 cos theta is equals to 0. This is equation 1, okay. Can we substitute some of the values here? Okay, we can substitute some of the values like R1, okay. Now R1 we have as how much? 100 cos theta, right? So from the equation 1 here of the block 100 newtons, hence you can just substitute cos theta minus 200 cos theta is equals to 0, okay. Now R2 is equals to what you can write finally, 300 cos theta. This is equation. Now you can just write it as 3 and this as 4, because 1 and 2 we already have, okay. Now so when we have done that, we can solve the next steps. R2 is done. Now sigma h is equals to 0. Now for horizontal forces, what we have to look at the sketch once. See, for horizontal forces we have 0.3 R2 and 0.3 R1, and also the horizontal component of this inclined force 200 newtons, okay. So now what all forces we can take, that is 0.3 R1 plus 0.3 R2 and minus 200 sine theta. Why minus 200 sine theta? We can have the sketch once again, no issues. You can draw this clearly to understand it in a better way. So this is block 200 and this is the axis. So this is the load that is coming 200 and this is theta made, and this is 0.3 R1 and this is R1, which is equals to 100 cos theta. We got it when we were solving block 1, and because of the 200 newtons, a reaction will be developed here that is equals to R2. Since the motion trend is towards down, this is motion trend, okay. Hence the friction will be towards right. So 0.3 R2, okay. That's it. So now what were the horizontal forces we had? 0.3 R1 towards right, positive. 0.3 R2 right side, hence positive. And And what about this inclined force? Once it gets horizontal, it will be directed, you just shift this like this, it will be directed towards left, hence it is minus 200 sine theta is equals to 0. Now what is r1? You can substitute 100 cos theta plus what is r2? It was 300, what was that? 300 cos theta minus 200 sine theta is equals to 0. So this will be 30 cos theta plus 90 cos theta minus 200 sine theta is equals to 0. So you'll be getting sine theta by cos theta is equals to 120 by 200. Hence tan theta, sine theta by cos theta is tan theta, so it will be 0.6. Therefore your theta will be around 30.934. So you got an angle as, how do you get this? Theta is equals to tan inverse of 0.6. You will get theta is equals to 30.934, and you substitute this theta is equals to 30.934 in equation 2. Substitute in equation 2. When you substitute in equation 2, what do you get? T is equals to 100 sine 30.934 plus 30 cos 30.934. You'll get T approximately around 77.14 Newton. So you got the angle of inclination as theta is equals to 30.934 and the tension in the string as 77.14. Thank you.